Everybody has heard of the Mediterranean Sea, I'm sure. And I'm sure you also remember why it is called Mediterranean, middle of the earth, because originally, before the Common Era in the BC, before the Common Era, people didn't know the entire configuration of the continents and Earth, so they sat in European countries and north of Africa and said, this is the world, right? So Tethys Sea preceded, but Mediterranean was part of the Tethys Sea, and here we see it in the modern configuration. Has a very narrow opening here in the Strait of Gibraltar, and is heavily divided into multiple basins by the topography and the islands. So Italy comes way down here. Sicily is almost touching Algeria here. You know why migration effects are high on Greece and Sicily and Spain and so on. People can cross much easily here, and some parts here. Nonetheless, you have Abyssal Plains here, as deep as 2,800 meters, and this one is more than 3.5 kilometers, more than 4 kilometers, and so on. So it's divided into Adriatic Sea, there is the Mediterranean Ridge, the Cyprus Sea, and the Baleario Islands are here, and so on and so forth, right? Mediterranean climate is a terminology by itself, which is generally dry, sunny climate, considered nice. You get some good vineyards, good food, good wine, and so on and so forth, right? So many interesting things emerge out of this, and you can see that somewhat here. The surface water is actually flowing out of the ocean below the surface. The Mediterranean water is flowing out below the surface at the bottom of the sill here in the Strait of Gibraltar, and the Atlantic water is coming in. So it is reversed compared to the estuaries we have been seeing, where estuarine flow, lighter water at the surface was flowing out, and the ocean heavier water was coming in. Okay, whereas here we will see that various atmospheric ocean interactions create heavy water here. In fact, some of the waters that are living here are heavier than the Antarctic bottom water. We said Antarctic bottom water was the heaviest water that sinks like a rock to the bottom in the Southern Ocean, whereas here you are producing very heavy water. Even though temperature is high, you are evaporating so much that you are producing high salinity heavy water, which is flowing out at the bottom, mixes along the way, and becomes Mediterranean intermediate water, which we saw in that temperature salinity plot. TS diagrams are very common. They are known as TS diagrams, temperature salinity, which show the density lines, right? So Adriatic Sea in fact forms the so-called Adriatic bottom water, and that water slowly flows across out of the Mediterranean. So Mediterranean has very irregular coastline, as you saw here. It has a sill underwater ridge from Sicily to Tunisia, dividing the Mediterranean into two major basins. There are strong currents through the Strait of Messina over here, and so on. And the main thing to remember is that the Mediterranean circulation means ocean water is lighter and is coming in to the regional sea at the surface, and the local waters are heavier and they're flowing out at the bottom, okay, because it has very high rates of evaporation. If the groundwater and the runoff from the continents didn't compensate, Mediterranean would keep evaporating away. And it turns out that the ocean water coming in also obviously contributes to maintaining the volume. As long as there is space for it to flow in, it can add to the evaporating water and do the mass balance, right? But something did happen in the past, okay? It is called a Messinian Crisis. Okay, let's look at the circulation and then try to explain it. So here is Portugal, Spain. I think the Strait of Gibraltar is only about 9 miles 45 kilometers wide, and it's only about how much, a couple of 100 meters deep, you can see here. So you can see the heavy, warm but very salty Mediterranean intermediate water is coming out. When it's leaving here, it can be heavier than Antarctic bottom water, which is the heaviest water in the open ocean, and sink to the deeper ocean, obviously because it's so heavy, and then mix along the way before it mixes into the thermohaline circulation that we talked about. So the low, cool Atlantic water is coming in. Okay, and here you see this circulation and the evaporation creating heavier water. What happened 6 million years ago? Essentially, somehow either the sea level dropped and the ocean water couldn't flow in which case the evaporation would continue to provide lose water, or somehow the evaporation became so large and the runoff from the land and so on became so low that the ocean couldn't compensate for the evaporative losses. How do we know this? They can go and take a core at the bottom of the Mediterranean Sea and they find a mile-high salt from 6 million years ago. Remember, we used radioactive isotopes to date past climates. So you can use things like carbon dating only goes back to about 50,000 years ago, but you will need other isotopes to go back 6 million years, and there are many that can do that, as we saw before. So using these paleoclimate evidences, we know that there was a Salinity Crisis about 6 million years ago, which is called the Messinian Crisis. It's a nice physics problem to explain how this could have happened, right? As I said, either sea level dropped and the Strait of Gibraltar didn't allow the Atlantic waters to come in anymore, or some other processes that happened that prevented the Mediterranean from maintaining its salt balance, and it kept building mountains of salt at the bottom. Very interesting.